In this module, you will learn about the basic terminology of a parabola and to derive the standard equations of a parabola. You know that when a plane intersects one nape of a cone at any place other than the vertex, such that angle beta between the plane and the axis of the cone is equal to angle alpha between the axis and the generator of the cone. The resulting conic section is a parabola. If you throw a solid object in the air at an angle to the ground, the trajectory of the object is a parabola. Consider a fixed straight line L in a plane. Also consider a fixed point F in the same plane but not on line L. Now consider points P1, P2 and P3 such that their distances from the fixed line L and the fixed point F are the same. Then the curve passing through all such points is a parabola. Thus, a parabola is the set of all the points in a plane that are equidistant from a fixed line and a fixed point in the plane. Remember that the curve of a parabola forms only if the fixed point F does not lie on the fixed line L. If point F lies on line L, then the parabola becomes a straight line. This is also called the degenerate case of a parabola, explained earlier. The fixed point F in the plane is called the focus of the parabola. The fixed line L in the plane is called the directrix of the parabola. The line passing through the focus and perpendicular to the directrix is called the axis of the parabola. A parabola is symmetrical about its axis. Thus, the axis of a parabola is also called its axis of symmetry. The point where the axis intersects the curve of a parabola is called the vertex of the parabola. The line segment passing through the focus, perpendicular to the axis and with its endpoints on the curve of the parabola, is called the lattice rectum of the parabola. If we consider a parabola with its vertex at the origin and its axis along the x or y axis, then there are four distinct possibilities. We can have the axis of symmetry of the parabola along the x-axis with the focus of the parabola on its positive side and the directrix cutting the negative side. Here, note that since vertex O is also a point on the parabola, its distance from the focus and the directrix will be the same. Thus, if the axis of symmetry lies along the x-axis, the vertex lies at the origin and the focus at A, 0, then the directrix will intersect the x-axis at -a, 0. As another possibility, we can have the axis of symmetry along the x-axis with the focus of the parabola on its negative side and the directrix cutting the positive side. We can also have the axis of symmetry along the y-axis with the focus of the parabola on its positive side and the directrix cutting the negative side of the y-axis. Or we can have the axis of symmetry along the y-axis, the focus of the parabola on its negative side and the directrix cutting the positive side. Let us derive the equation of the parabola for case 1 with the axis of symmetry along the x-axis, the vertex at the origin, the focus at A, 0, and directrix intersecting the x-axis at -a, 0. Consider a point P on the parabola with the coordinates x, y. Join P to F. PF is the distance of point P from the focus of the parabola. Let PB be the perpendicular drawn from point P on the directrix. Thus, PB is the distance from point P to the directrix. Since point B lies on the directrix, its x-coordinate will be -a. The y-coordinate of point B will be the same as that of point P, that is, y. We already know the formula for calculating the distance between two given points. Substituting the coordinates of points P and F in the distance formula, we get distance PF is equal to under root x minus a whole square plus y square. Let this be equation 1. Similarly, substituting the coordinates of points P and B in the distance formula, we get distance PB is equal to under root x plus a whole square. Let this be equation 2. By the definition of a parabola, distance PF is equal to distance PB. Equating the values of PF and PB from equations 1 and 2 and simplifying, we get y square is equal to 4ax. The equation y square is equal to 4ax represents the given parabola. Let us see if the coordinates of P as derived from the previous equation satisfy the geometrical condition stated in equation 1. Substituting the value of y square as 4ax in equation 1, we get PF is equal to PB. Thus, the geometrical condition is satisfied. Thus, the equation y square is equal to 4ax represents the parabola with the axis of symmetry along the x-axis, the vertex at the origin, the focus at a, 0, and directrix x is equal to -a. By similar derivation, the equation of the parabola with the axis of symmetry along the x-axis, the vertex at the origin, the focus at -a, 0, and directrix x is equal to a, is y square is equal to -4ax. The equation of the parabola with the axis of symmetry along the y-axis, the vertex at the origin, the focus at 0, a, and directrix y is equal to -a, is x square is equal to 4ay. And the equation of the parabola with the axis of symmetry along the y-axis, the vertex at origin, the focus at 0, -a, and directrix y is equal to a, is x square is equal to -4ay. These four equations are called the standard equations of a parabola. Here, we can make some interesting observations. Note that if the equation of the parabola has the term y square, then its axis of symmetry lies along the x-axis. If the equation of the parabola has the term x square, then its axis of symmetry lies along the y-axis. Also note that if the axis of symmetry lies along the x-axis, then the curve of the parabola opens to the right if the focus lies on the positive side of the x-axis, and the curve of the parabola opens to the left if the focus lies on the negative side of the x-axis. Similarly, observe that if the axis of symmetry lies along the y-axis, the curve of the parabola opens upwards if the focus lies on the positive side of the y-axis, and the curve of the parabola opens downwards if the focus lies on the negative side of the y-axis. Now, let us find the length of the lattice rectum of a parabola. Consider a parabola with lattice rectum AB. Let the distance OF between the vertex and the focus of the parabola be A. Since the distance of the focus and directrix from the vertex is the same in a parabola, we have distance FM is equal to 2A. Let us draw a perpendicular AC from point A to the directrix. Now, the distance AC is equal to FM. Thus, the distance of point A from the directrix is 2A. Since point A lies on the parabola, its distance from the focus F and the directrix must be the same. This implies that AC is equal to AF, or AF is equal to 2A. Since a parabola is symmetrical about its axis, distance FB is equal to distance AF, which is equal to 2A. Thus, the length of the lattice rectum AB is equal to 4A, where A is the distance between the focus and the vertex of the parabola. In this module, you learned that a parabola is the set of all the points in a plane which are equidistant from a fixed line and a fixed point. A parabola has a focus, a directrix, an axis of symmetry, a vertex, and a lattice rectum. A parabola with the axis of symmetry along the x or the y-axis and the vertex at the origin has four possible orientations represented by these four standard equations. The length of the lattice rectum of a parabola is equal to 4A, where A is the distance between the focus and the vertex of the parabola.